Good evening and good morning. My name's Peter Rushforth and I work for Natural Resources Canada's Centre for Mapping and Earth Observation in the Canadian Geospatial Data Infrastructure Division. Today I want to talk about why we need to standardize maps for the web in HTML. There are many reasons that people need or want to make web maps. In the domain in which I work, it's a requirement of most projects. But how do you make a web map? It's easy, right? There are lots of ways to make a web map. You just need to pick a framework. Each framework has its merits. Some are easy to get started with. Some come with a bunch of free data layers built right in. Others require significant knowledge and/or manipulation of data and access to computing resources. Accessibility is not guaranteed and it's easy to mess it up. Interoperability pretty much does not exist. In short, there is no simplest choice and it can be a big decision. Once you decide, all the code that you write does belong to you, except it's bound to the framework you've chosen, making any change expensive and painful. The result? The result is silos. Although each web mapping framework is somewhat similar, none share the same foundation and they are not interoperable except in that the user can see a map. The result is bad for users and the web. Why do silos exist? Silos might be caused by proprietary interests, such as those created to lock users into software platforms. But more likely they exist because we didn't take the trouble to collaborate and eliminate the barriers or to create interoperability. The proposal we'd like to make in this workshop is, why don't we work together to support all the users? Mapping framework providers are all trying to serve their users. Collectively, the sum of their users is approximately equivalent to humanity as a whole. All the map providers use the web as their medium of choice to deliver their products. Together, let's improve the web to serve all of the providers equally well, possibly reducing their individual frameworks' responsibilities. Let's make a standard that helps with the common core that these providers can progressively enhance if need be. Let's make a standard to serve users' needs directly through common accessibility, privacy, safety, linguistic, and usability infrastructure, just as we try to do for users in the real world with roads, bridges, sidewalks, crosswalks, signs, etc. While we're at it, let's make the standard a natural first step in learning so that maps can be taught at school, giving children a common starting point for learning about geography and the web without frameworks. Can silos truly disappear, though? The test of independent invention, first described by Tim Berners-Lee, is a kind of thought experiment. The notion is that any new protocol or format must be designed for introduction into an environment that has incumbents, or it cannot succeed. At the invention of the web, for example, FTP, Gopher, WAIS all existed in the mainstream already. HTTP, HTML, and URLs were designed to work with the existing protocols, somewhat satisfying the test of independent invention, which can never be perfectly resolved. You can't make silos disappear, but over time they can resolve on their own. In the real world, infrastructure often describes public facilities created for the benefit of all without prejudice. Such infrastructure must be safe and accessible, safe for everyone to use. It must be fair and inclusive. What good would roads and bridges be if you could only drive a Ford on them? It must be durable, because everybody uses it. Infrastructure must be built to serve and last. And finally, it must be cost effective. Infrastructure should make it less costly for everyone to achieve their goals. Note that this does not mean that it's free. In fact, it can be quite costly, but it should be maximally shareable. In the virtual world, the World Wide Web and the software that supports it is virtual but nonetheless real infrastructure. But how do we avoid creating more silos in standardizing maps and spatial data for the web? The situation in web mapping standards is a little bit like this XKCD comic. There are probably more than 14 different ways to create a web map, and trying to make the situation better by adding another framework risks creating a worse situation. So what to do? Can we fix the situation by adding another standard? Probably not. Many existing formats for geospatial information already exist. If one of them was suitable, it probably would be a web standard. The challenge is to create a new format that enables web maps without requiring web browsers to radically change or change their architecture, which is impossible. Proposed solution is to add and extend mapping elements in HTML. HTML is widespread, and it's the foundation of web architecture, and browsers are based on processing it. The bonus is that HTML already implements basic map semantics. HTML, pictured here, is the core language of the web, and it was designed to bridge the divide between programmers and users. Ideally, it allows everyone to have access to content regardless of ability. Further, it is straightforward enough to allow users to become authors. This is embodied in the idea of view source culture, in which the medium itself teaches the user what is possible and how to achieve it. Why are maps in HTML preferred over maps in JavaScript in the future? Because HTML requires and delivers interoperability, the browser will become a spatial integration platform. Shared standardized semantics mean interoperability. Discovery. Because of the rule of least power, web pages could have location. Indexing pages by location, search engines will become spatial discovery platforms. HTML requires and delivers inclusivity, understandable and creatable by authors who are not necessarily programmers, or authors who are not necessarily mappers for that matter. HTML requires and delivers accessibility. Because things, not just web pages, have location, the browser will tell the user about their physical environment as described by a web map or website. For public spaces, real infrastructure will be represented also as virtual infrastructure. HTML requires and delivers performance. Less runtime costs to HTML than to JavaScript mean map rendering is better and more suitable for native code. HTML requires and delivers scalability. Related to performance and inclusivity, and possibly other aspects of this list, scalability means maps will work in constrained or powerful environments. HTML is like the standard library of the web. A single element encapsulates processing steps, especially rendering, from the layers below. Maps and location belong in the web's standard library so that sophisticated applications can be built on top of the web without having to reinvent the wheel. HTML is simple enough for a web crawler to understand, but scales to underlie very sophisticated application development. Even though modern web crawlers can execute web applications to reveal the application-generated HTML and text content, they can't understand semantics that aren't there, such as maps and location, which don't exist yet in HTML. Standardized location is important not only for search and discovery, but also for accessibility and internationalization. A key aspect of HTML is that it is standard. Its elements have defined visual and accessibility semantics, making it inherently inclusive. Adding maps to HTML could aid important use cases for users, such as search and discovery, reducing the need for special purpose catalogs, and the same linkability or web superpower that allows crawlers to enable search and discovery will also enable map service federation and location information sharing. HTML is inherently cross-platform, making it the ideal target for standardizing location information. These aspects taken together mean that maps in HTML will be more economically effective than our current silos, leading to better return on investments for society. HTML was a massive decade-long effort, and there's little appetite in the web standards community to repeat such an effort. HTML does, however, constantly change, and today the HTML standard itself is evergreen, with new ideas being integrated and browsers implementing constantly. So how does the process work? Ideally, developers like us who use JavaScript, HTML, and CSS provide feedback to the web platform engineers who prioritize implementing low-level features that are of use to the largest number of people. Often, these features are of JavaScript, but also of CSS and HTML. As low-level features are implemented, the thinking goes, developers will develop high-level features as libraries or custom elements. As the high-level functionality that becomes widely used, it thus becomes an emergent or de facto standard. These de facto standards can then be implemented natively by browser developers, giving rise to wider and improved use of the web and consequent generation of new requirements from new communities like our own, participating in the virtuous cycle, and so on. That maps are an emergent characteristic of the web, even constituting a GeoWeb, is obvious to the most casual observer. Maps in the HTML of the future might look like this, starting with a map element containing one or more child layer elements. There already exists a somewhat neglected map element in HTML with similar enough semantics to provide a good extension point, in keeping with the HTML design principles. By specifying a new child layer element, HTML could immediately incorporate dynamic web map semantics as commonly understood, providing the shareable infrastructure that web maps and geospatial information require. HTML has evolved over time. It began as simple text documents linked together. It was the linking that made them special. Linking has been described as the web's superpower. Over time, media types have been added in response to user needs, and most recently with the advent of the mobile web and responsive design. Maps should be the next big thing. So, where actually is this virtuous feedback loop of which I spoke? The Maps for HTML community group was created based on the conviction that web mapping is an emergent or de facto standard of the web, as sought by the Extensible Web Manifesto. The main way to provide feedback to the browser standards community is for you, especially representing your organization or company, to join the Maps for HTML community group to contribute ideas, comments, and even code. Another important path for feedback from web mapping community to the web platform folks is the annual Mozilla Web Developer Needs Assessment, or Web DNA survey. Please share the link. Mention web mapping. Mention maps in HTML. A key feature of the URL-driven web of HTML is the ability to share documents using their URL. This feature of the web also enables linking within and between resources, not to mention search and discovery. The simple architectural characteristic could make a GeoWeb of the future a benefit to users around the globe and to the interests that rely on it, in other words, everyone. HTML will provide a common foundation for maps and location for all stakeholders. Spatial information is infrastructure, and a standard that represents its common foundation will unlock the true value of that infrastructure. Maps, standardized in HTML, will allow us to encode and share our understanding of the world. Let's achieve the understanding of our physical world by enabling the representation of that world in HTML together. Thank you.